Okay, today we are going to investigate intercepts. Does that sound like fun? We have x-intercept to learn about, and we have the y-intercept to learn about. So let's just get going. Y equals mx plus b. Does anybody remember what that thing's called? Y equals mx plus b? Huh? Slope-intercept form. Very important that you know that. Y equals mx plus b is called slope-intercept form. So if I ever say we need to put this in slope-intercept form, you know what I'm talking about. Y equals mx plus b. Okay, m, we've talked about what m means, and m stands for slope. That's your amount of steepness to a line. And b is the y-intercept. Why do they have a letter B represent the y-intercept? I don't know. Okay. B, we just said, it's also called the y-intercept. And it's also the initial value, like when we were doing initial value and constant rate of change before. So today you're going to learn about specifically the y-intercept. It is the point where the graph crosses the y-axis. And the coordinates for any point on the y-axis is always 0 something. It's whatever your y-coordinate is. Or we could say 0 whatever your y-intercept number is, b. So let me just show you what I'm talking about for a second. Okay, just grabbing a coordinate plane here. Which one is the y-axis? It's the one that's vertical. So I'm just going to plot a few random points. It doesn't really matter which ones I plot. Okay, and I'm going to write down their ordered pairs. So you don't need to write this down. I just want you to watch. Okay, let's start down here. Can you tell me what the ordered pair is for this? 0, -2. We don't go right or left. That's why the x-coordinate 0. We just go down 2. How about the ordered pair for this one? 0, 1. We don't go right, we don't go left, we just go up 1. How about this guy? 0, 2. And how about that one? 0, 4. What do you notice about all these points? What do all these points have in common? They all have an x value of 0. So whenever you want to know something about the y-intercept, the x-coordinate is always 0. Because if you want to be on the y-axis, which is what a y-intercept is, it's something on the y-axis. If you want to be on the y-axis, you can't be right or left any. Because if you're right or left any, you're no longer on the y-axis. So the only way to be on the y-axis is to have an x-coordinate of 0. Okay, so y-intercepts always, always, always have an x-coordinate of 0. Okay, let's go back to the paper for a second. So that is why whenever we're talking about y-intercepts, we always have a 0 where the x is. Now, if the graph crosses the x-axis, the point is called the x-intercept. And its coordinates are always, whatever the x-coordinate is, 0. The x-intercept is also called the 0 of the function. And when you're talking about the equation y equals mx plus b, you do not see the x-intercept in this equation. The only thing you see in this equation is the slope and the y-intercept. You do not see the x-intercept, so the x-intercept cannot be found in this equation. Okay, so I'm just going to go back to my board for a second. And I'm going to plot some points on the x-axis. So just some random points on the x-axis. Okay, this one, what is that ordered pair? Right 1, don't go up or down, so it's 1, 0. How about this one? 1, 2, 3. Right 3, don't go up or down, 3, 0. How about this one? 5, 0. Very nice. And how about this guy over here? Negative 2, 0. These are called x-intercepts because they're on the x-axis. And what do you notice they all have in common? A y-coordinate of 0. So if you ever want to know something about the x-intercept, its y-coordinate will always be 0. And if you just stop and think about that for a second, if you're going to be an x-intercept, you have to be on the x-axis. And the only way to be on the x-axis is to not be up or down off of it, which is why the y-coordinate is 0. That way we're not up or down off of it. If I'm down off of it, my y-coordinate's not 0 anymore, and I'm not on the x-axis. Okay, so x-intercepts always have a 0 for the y, and y-intercepts always have a 0 for the x. The 0 is always in the opposite letter. Okay, back to our paper. Okay, this first graph we have here is an example of draining a pool. We see our water level in feet versus, we don't have it labeled here, but this is our time in minutes. Okay, the first thing it tells us to do is to circle the y-intercept and write the coordinates. Okay, so the y-intercept, that's where the graph crosses the y-axis. So here's our y-axis, and it doesn't have to cross, it can just touch. So wherever the graph touches or crosses the y-axis, and that's our y-intercept right there. And what are its coordinates? 0, 8. So y-intercepts always have a 0 for the x-coordinate. Now I want to know, what does that y-intercept mean? The 0 is the x value, and x is talking about time. The 8 is the y value, and the y value is talking about your water level. So what does it mean? 0 up to, 0 to 2, up to. So if I take the change in my y, 2, and I divide by the change in my x, 2, and that's what I get the whole way through the table, that reduces to be 1. And that's my slope. Okay, in order to write an equation of the line in slope-intercept form, we only need to know two things. We just need to know our slope and our y-intercept. And we just found both of those things. We just found the slope to be 1, so I'm going to put the 1 right where the m is. So it's going to say y equals 1x. And then the b, the y-intercept, is this guy. So this guy is our b, that negative 4. So instead of writing plus a negative 4, I'm just going to write minus 4. The other way of writing this is y equals x minus 4. You don't actually have to write the 1 in front of the x. I just did it so you knew that that's where the slope went. Okay, number 5. Let's look at that one for a second. Uh-oh, we have numbers missing. Okay, we have to try to figure out what's going on here. So I'm going to see if I can fill in these spaces. What's it look like is happening? What do you think would be between a negative 1 and a 0? I'm sorry, a negative 1 and a 1. Oops, I spilled the beans. It's a 0. Then it goes from 1 to 3, and then it's 3 blank 5. So what do you think's between 3 and 5? Okay, a 4. So now I need to figure out what's happening with my y's. So let's just look here for a second. To get from 1 to 3, you go up 2. To get from negative 12 to negative 4, what do? You go up 8. Okay, so I know that if I want to find my slope, I take the change in my y, which is 8, over the change in my x, which is 2, and that reduces to 4 over 1. So it's going up by 8 when you go by 2's, but it's going up by 4 if you're going by 1's. So to get from negative 1 to 0, I'm going up 1. So when I'm moving by 1's, my change in my y is going to be going up by 4's. So if I go up by 4, what would this y right here be? A negative 16. Okay, to get from 3 to 4, I'm going up by 1. So when I'm going up by 1, my y's should be going up by 4. So if I'm going up by 4, how do I get from negative 4 to here? Negative 4 plus 4 is 0. Okay, so let's find our intercepts real quick. Remember, if we're looking for intercepts, we want to look for our zeros. So here I see a 0, here I see a 0. Okay, now when the x-coordinate is 0, which intercept is it? That's right, it's the y-intercept. And when the y-coordinate is 0, that's the x-intercept. Okay, so let's come down and fill that information in. So here I see y-intercept, and I know my y-intercept 0, negative 16. Now notice this time it didn't actually ask for the x-intercept, it asked for the 0 of the function. Remember, the x-intercept is also called the 0 of the function. So whatever the x-intercept is, that's your 0. Lots of terminology today. I'm sorry, are you on brain overload? Okay, we're almost done. Bear with me. Now if I want to write the equation, I'm going to put it in slope-intercept form, y equals mx plus b. Remember, I only need to know two things in order to do this, my slope and my y-intercept. So what did we figure out the slope was? We found that it was the change in the y over change in x, 8 over 2, which is 4. So it would be y equals 4x. And then our y-intercept is the 0, negative 16. So all I have to write is the minus 16. And that's the equation of the line that's represented by this table. That one was a little more challenging. We're going to practice this next time I see you, so don't worry. Okay, one more. I want to find the intercepts from the graph, then I'm going to find the slope, and then I'm going to write the equation of the line. Okay, so wherever the graph touches the x-axis, that's called the x-intercept. Can you guys count and see what ordered pair that is? That's right, it's 2, 0. Remember, x-intercepts always have a 0 for the y. And remember, the x-intercept's also called the 0 of the function. Okay, the y-intercept, that's where the graph crosses the y-axis. So wherever the graph touches or crosses the y-axis, that's the y-intercept. Can you take a moment and try to count that? And that's right, it's 0, negative 4. Okay, slope, I'm going to count what I rise over what I run. And to get from here to here, I rise 1, 2, 3, 4. So my rise is 4. And I run 1, 2. So my run is 2. But I can reduce that to just a 2. Okay, and if I want to write my equation, I'm going to put it in slope-intercept form. Remember, I only need to know two things, my slope and my y-intercept. Do we know those two things? Yes, we do. So what do you think the equation would look like? Y equals, what's the slope? 2. 2x. What's the y-intercept? Negative 4. So minus 4. There she is. Smiley face. Done. Sorry so long.